You're with Dave Staublin. We're solving some systems of equations using matrices. Step number 1, represent the system of equations using matrices. And here we go. The coefficients are 2, 3, 4, 6. The variables are x and y. The constants 4 and 9. We'll label these A, X, and B matrices. We're going to solve by finding if the inverse exists, and if it does, multiplying it in the equation and solving it. So first of all, does the inverse exist? Well, let's find the determinant of A to determine if it exists, and it will be the A and the D values minus the B and the C values. So we get 12 minus 12 equals 0. Guess what this means? No inverse matrix exists. So that means there is no solution. But here's what we got to do. If you recall, there's 3 ways that linear lines can intersect. You can get one solution where they cross. They could be parallel, which would be no solutions, or you could have the same line on top of each other, and that would be infinite solutions. So infinite solutions, 0 solution, or 1 solution. So the question then is, which situation is this? If an inverse doesn't exist, there's no solution. It's going to be one of these two, or certainly it means you can't solve it. So let's look at this. Equations up here. If we take this top equation and we multiply it by 2, we end up with 4x plus 6y equals 8. Look at these, have the same coefficients in front of the x's and the y's, but the constants are different, so they're not the same line. They have to be parallel lines. So 0 solutions.